Welcome to the world of data science. And in this video, we are going to discuss about chi-square statistics. And I have split the overall video into two different videos, part one and part two. And in part one, we are going to discuss about one example problem for chi-square statistics. And in part two, I've covered the actual interpretation of this chi-square and when do we use a chi-square test? And there are a couple of example problems also to help you identify to check your knowledge level on whether or not we use the chi-square test for a given data set. And that is covered in part two. All right. Let's jump on to the definition. What is chi-square test? It is the whole bookish definition is given here, but in short, we use chi-square test to identify the test of independence or test of relationship to identify whether or not two categories or two items are related. If you want to identify that, then that is where you should use chi-square test. And the formula is given as observed data minus expected data, the whole square divided by observed. And this expected definition is also given here. And in addition to that, we are also supposed to identify the degrees of freedom from the given data, which is given by R minus 1 into C minus 1, which the way why we need to identify the degrees of freedom is beyond the scope of this video. But for now, you can assume that it is just R minus 1 into C minus 1 is going to be the degrees of freedom for the given data set. Let's jump onto the problem directly. Now, in this given data set, the question here is if you want to check if there is a relationship between a person's travel time to office, right, or is related to his observed stress level. The stress level is related or not with respect to his travel time, and that is a question here. The person may be going by walk or bike or car or whatever it is, but the question here is whether or not they are related to each other. And to identify that, like I said, this is a test of independence, and hence we can use the chi-square test. To identify the chi-square test, we need to always take H naught as the null hypothesis, which is nothing but it has to be always taken to be no relation between two data set, which is travel time and the stress level. That is the interpretations. That is the standard that we should always take. And in H1, we should take that there is a relationship between the travel time and the stress level. Now, the degrees of freedom can be identified using this formula. Here, the number of rows are given by 3 rows, and hence 3 rows minus 1 is going to be 2. And similarly, there are 3 columns, and hence it is given by 2. So, the total degrees of freedom is given by 4. And it is also given that the alpha, which is nothing but the level of significance, that is given as 1% level of significance in the given problem statement. But sometimes if it is not given, you should probably default to 1% significance level. That is acceptable always. All right. Now, to identify the chi-square value, we first need to identify the expected frequency. And to find the expected frequency, you should apply this formula. This is nothing but the row sum into column sum and the total sum divided by total sum. Now, to fill this cell, remember that the denominator is always 116, which is nothing but the total value. Okay, so in all the cell values, we should always divide the total by 116, which is the total value. And in the every cell, you should probably identify this row sum into column sum. So this is the row sum and this is the column sum. It's given here. Now for this cell, you should use the respective row and then the respective column. Because this is 1 comma 1, you should use 32, which is this row level sum into this column level sum divided by total value. Similarly, for this one, you should use 32 divided by into 19 divided by 116. And similarly, for this value, 32 into 53 divided by 116, and so on and so forth. So ensure to use for the respective row and the respective column for the given cell. Now, if we calculate the expected frequency, this gives us 12.14, 5.24, and so on and so forth. Now, we have been given with this data set, which is the observed stress level, and this is the expected level. Now, if you look at this data, we see that there is a little bit of deviation from the expected level versus the observed level, right? And that is what is going to be given with the chi-square test. Now, to provide the chi-square, to calculate the chi-square value, we should apply this chi-square formula, which is nothing but observed minus expected the whole square divided by expected value. Now, we have been given with the observed value. In the previous slide, we calculated the expected value. Now, we can easily identify the summation. Now, this can be given by 9 minus 12.14, the whole square, divided by 12.14, because 12.14 is the expected value. And similarly, for this cell, you should use 5 minus 5.24 divided by 5.24, which is nothing but the expected value. And similarly, for this value, you can identify that 18 minus 14.62 divided by the whole square divided by 14.62. Don't forget to square the value. That is very important. Otherwise, you will not get the actual result correctly. Now, we found the chi-square table. Based on previous slide, we got this formula, and then the output of this value is given as 0.81, 0.01, 0.78, and so on and so forth. Now, once we find the chi-square value, we should do the summation as well. To do the summation, I've just easily summed up the column value first. Like this column sum value is given by 4.6, and similarly this column sum is given by 0.23, and similarly this column sum is given as 4.99, and then the total sum is going to be 9.82. This is nothing but the chi-square value. Alright, and this is the observed chi-square value or calculated chi-square value. Now, the question is not to identify the chi-square value, rather to identify whether or not there exists a relationship between the travel time and the observed stress level, right? Now, to do that, remember that we have already taken that H naught to be always no relationship between travel time and stress level. And based on that, we got chi-square value to be 9.82. But we need to also identify using the chi-square frequency table using the chi-square value for 1% level of significance, and that is given by 13.38 or 13.28, basically 30. And that is calculated based on this chi-square distribution table. We should calculate, we have already calculated the degrees of freedom to be 4, and this is for 1% level of significance, and this is for 2.5% level of significance, and this is for 5% level of significance. And for in our case, we are going with 1% level of significance, and hence it has to be 13.28, and that is the value that we have got. Now, the way how we should interpret this to be is, this is again another curve, right? This chi-square curve is also given something similar to this for this degrees of freedom. But this 13.28 is somewhere given here. This value is somewhere given here as 13.28, right? Now, by definition, we should always take this as the acceptance region for H naught. This is always H naught acceptance region, and this value is going to be H1 acceptance region, right? Now, whether or not we accept the given relationship or not is dependent on the calculated value, which is nothing but 9.82, and this 9.82 is going to somewhere fit in here, which is nothing but this is in the acceptance region, and that is what we infer that to be. If you look at the actual curve, right, this is the example curve. Like I said, all these values are acceptance region beyond 13.28. 13.28 is from the table value. the chi-square distribution table value, and anything in this side is for H1 acceptance region, and anything on the left side of the chi-square value is going to be H0 acceptance region. And now, since our 9.82 is lying within the acceptance region of H0, we take H0 to be accepted, which means there is no relationship between travel time and the stress level, and that is the inference here. I hope this helps you to identify the exact chi-square value and how do we take the distribution value to interpret whether or not there exists a relationship. But if you are still not sure about how to identify whether the given problem is to be solved using chi-square or not, please feel free to watch part 2 of this video, where I've explained in detail how do we identify whether the given problem statement is falling under a chi-square test or not. Alright, thanks for watching this video. Please keep watching this space for more information about the data science and the statistics value as well. Thank you.